This is the question from the 2019 Central Province paper, the network question. It says an office has 4 sections called as sales, planning, training and admin. So there are 4 sections in the office. We have the office, 4 sections. One is called as sales, other one is called as planning, next one is training and admin. There are 4 sections of the office. The office has obtained the IP address block. The entire office has taken the IP address block 220.6.0.24. Right. Now they have given the IP address in this level. Is this to say that this is a class full or classless IP? This is classless because of this /24. So that these IP addresses are not belong to any of the classes. Right. Then I will go to the rest. It is required to subnet and provide the IP addresses to the branches. Now this IP address block has to be subnetted to have 4 subnetworks. Why? There are 4 sections of the organization. Further, this says that sales, training, planning and admin need 45, 60, 30 and 10 addresses respectively. So that sales section need 45 addresses, planning section needs 60 addresses, training needs sales need 45, training need 60 and planning need 30, as well as admin requires 10 addresses respectively. Addresses means they need this much of computers or addresses. Right. The first question says how many addresses are available in the IP block. So they ask how many possible IP addresses are there from the given IP block. Now we don't need to worry about the subnetting. We have to identify the IP address as well as the subnet mask. So the subnet mask is given as 24. Then what is the meaning of this 24? When you consider the binary format of the subnet mask, it is going to maintain 24 ones. So if you go to the binary format, we know that we need to have 8 bits in the first octet. 1, 2, 3, 4, 5, 6, 7, 8. And the next octet is also completely with ones. 1, 2, 3, 4, 5, 6, 7, 8. Other ones should also be 1, 2, 3, 4, 5, 6, 7, 8. Now we have 8, 16, 24. So this is what the 24 represents here. Then we need to have another octet that is completely with zeros. That means there should be 8 zeros. 1, 2, 3, 4, 5, 6, 7 and 8 zeros. So these are the subnet mask as they have given. Right. If I am write the ternary or decimal format of this one is, so 8 ones means 255. This is also 255 and this is again 255. Last octet goes for 0. So this is a decimal version of this one, but we need the binary version to consider the rest. Right. The question says how many addresses are available in the IP block. So if I go to the IP address 220, this is 220, then 32, next one is 6 and last one is 0. So according to the subnet mask, these 8 bits are representing hosts. So the last octet is representing host because of the subnet mask we have considered. This is to say that with this we can prepare all the host, all the IP addresses. Then really we don't need to worry about the IP address at this moment. From the subnet mask we can get it. Somehow the number of IP addresses are 2 to the power n. Here we don't need to worry about -2. Why do we use -2? That is to eliminate the network address as well as the broadcast address. Why? If I am going to assign IP addresses for the host in a network, we don't use network address and the broadcast address. So network address comes with all zeros and broadcast comes with all ones. So we don't use these two addresses for the hosts. That's why we remove two. But now we need number of IP addresses. Therefore, these are also two IP addresses. We don't need to worry about this minus 2. So that the possible number of IP addresses are 2 to the power n. What is n here? Number of zeros at the subnet mask. So here we have 8 zeros. This goes to the power 8, which is to say that 256 different IP addresses are possible. So this is the answer for the first one. Here we don't need to deduct 2. Why? They don't ask the number of hosts. They don't ask how many hosts are possible. They ask number of IP addresses. Therefore, it should be 2 to the power 8, 256. That's the answer. Right. Then the second part is the difficult section. It says indicate the network IP address, first and last IP address, and the subnet mask for each branch after subnetting. So now we have to consider the subnetting. So in order to consider the subnetting, we have to add subnet bits into the default subnet mask, into the subnet mask that we have prepared. So how do we go for the subnetting? What is the concept? In the question they have given that sales has 45 addresses, planning has 30, training has 60 and 10. Then the maximum number of addresses we need is 60. So with that we can start the question. Why? When doing the subnetting, we can have an equation telling that number of hosts goes to the power 10 minus 2, the one we had earlier. But they told that we need to have 60 addresses in the question. So if you consider that, we need how many hosts then? We'll just go for around 60. Now this is different than the earlier one. Earlier we consider how many total number of hosts are possible for the entire network. Now we are going for the subnetting. So we ask how many hosts per subnetwork. I'll write that. How many hosts per subnetwork. So we go for 60. Then we'll find n. What is n here? At this level, n will be the number of zeros to be maintained. Number of zeros to be maintained at the subnetted mask. Right. We'll find n to make the full answer into 60. So if I try n as 5, what would be the equation? 2 to the power 5 minus 2. 2 to the power 5 means 32 minus 2, 30. So this is giving you 30 hosts. Is that enough to fill 60? No. Then I'll increment that for the next value. N equals 6. 2 to the power 6 minus 2. This is 64 minus 2. Now it is 62. Is that fine? Yes, this is giving you 62 hosts. We need 60 addresses. So this is the answer. N equals 6. Then what is this n equals 6? Here we got it as n equals 6. What is the meaning of it? So we must maintain how many zeros? We must maintain 6 zeros at the binary format of the subnetted mask. Now we found how many zeros to be used in our subnetted mask. Then if I write the subnet mask now, then I can go for the new subnet mask. I must maintain 6 zeros. So I may go from the right hand corner 1, 2, 3, 4, 5, 6. That's all. To fill the octet, I must have another extra 2 ones. Then since it's subnet mask, all these should be ones. Then 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. As well as another octet 1, 2, 3, 4, 5, 6, 7, 8. This is subnet mask after the subnetting in the binary format. What would be what is it in decimal then? 255, 255, 255. These two, this bit is 128, this is 64. Adding together will make it as 192. So we found the subnet mask to be used in the subnetted version. Fine. Now we'll find what are the network addresses for each and every subnetwork used here. Right. Now we found the new subnet mask as 255, 255, 255, 192, and the IP block given is 220, 32, 6.0. So this IP block has to be subnetted according to subnet mask we have found. Then the best way is I may go for the binary version of all of them. Binary version of the subnet mask. That is 255 means 8 ones. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 1, 6 zeros. This is what we found earlier. And then I may go for the binary version of the IP address or IP block. So 220 in binary, that means 1, 1, 0, 3 ones and 00. Next one is 32. This is 128, 64, 32, 0, 0, 0, 0, 0. Other one is 0. 32, 6. 128, 64, 32, 16, 8, 4, 2, 1. And the last block is complete 0, 3, 4, 5, 6, 7, 8. Now these are the binary versions. So if you compare the subnet mask and the IP address, from the subnet mask we know that these two ones came extra because of the subnetting. So this is representing the subnet bits. And then if you go for these 6 bits, that is representing the last 6 bits are representing the hosts. And then all the previous ones are representing the network bits. Then we'll consider that. Now this is of the IP block is going for the subnet. Then by keeping that 0, 0, there is one subnetwork. Then I may go for the subnetwork 1. So there I am making the subnetwork bits. I may make subnet bits into 0, 0. Then I may write the decimal version. That's a little bit easy for me. This is 220. Then next one is 32, 6. So last block I may write it in binary 0, 0. And I want the network address as they have told in the question. We need to indicate the network IP address, first and last address of the subnet mask for each branch after subnetting. So then the first address of this one is 1, 2, 3, 4, 5, 6. That means this is 0. So that is the network address as well as the first address of the first subnetwork. In decimal complete it will be 220, 32, 6, 0. Then I have to go to the last IP. Last IP will be 220, 32, 6. I can't change the subnetwork. Then making all the bits once. 1, 2, 3, 4, 5, 6. Then what is this in decimal? This is 1, 2, 4, 8, 16, 32, 64. So this is 63. So these are the this is IP address range for the first subnetwork. The range comes like 220.32.6.0 to 220.32.6.63. In the same way, I may go for the subnetwork 2. Now I have to change the subnetwork bits. Subnet bits. So earlier 00, now I may go for 01. Now we'll see the smallest IP, which is the network address. That is, these are network bits 220, 32, 6. Subnetwork bits has to be in 0 and 1. Smallest means 1, 2, 3, 4, 5, 6. Then what is that in decimal? This is 64. Then I go to the next one, largest IP. That is 220, 32, 6. Network bits are maintained like 0, 1. All the host bits are made into 1. 1, 2, 3, 4, 5, 6. What is this in decimal? This is 64, 128. This should be 127. Then the range goes for 220, 32, 6, 0, not 0, sorry, 6, 64 to 220, 32, 6, 127. So this is the way we found the second subnetwork. So in subnet 3, I'll make the subnet bits into 1 and 0. Earlier we had 0, 1. If so, the smallest or the network address. Network address. Smallest IP or the network address. So in our IP block, the first octet is 220, 32, 6. Next two bits in binary are 1 and 0. Host bits are made into zeros. 1, 2, 3, 4, 5, 6. Then this is 1 to 8. Then the largest IP 220, 32, 6. Subnetwork bits are 1, 0, 1, 2, 3, 4, 5, 6. What is that? It goes so 191. And then we can have the range 220, 32, 6.128 to 191. I didn't write the first part. That's a subnet 3. Then we have one more subnetwork to be prepared, subnet 4. There I have to make the subnetwork bits into 1 and 1. That's the only subnetwork bit possibility we have. There are again the smallest IP, which is the network address of that particular subnet, 220, 32, 6.11, 1, 2, 3, 4, 5, 6. What is this? This is 192. And then we can go for the largest IP, that is 220, 32, 6 dot. Subnetwork bit comes as 1 and 1. Make all into 1. 1, 2, 3, 4, 5, 6. So then all ones means 2, 5, 5. So then this is what the IP address range. If I write range separately, it will be 220, 32, 6.1922 to 55. So then there are the IP address ranges as well as the network address of each and every subnetwork. So then this is a question that they ask, and we got the answer in this way. Then we can have another shortcut. Now in my case, what I did was I calculate the IP address ranges for all 4 subnetworks separately. Without doing that, I can do a small shortcut. After finding the IP address range for the first subnetwork, subnetwork 1 IP range, I got it. That is 220.32.6 dot. For the first subnetwork, it is 0 to 63. We got it. Then if I go to the second subnetwork, I found it like 220.32.6 dot 64 to 127. Then from these two, I may find a pattern and I may continue that pattern to the next two subnetworks, subnetwork 3 and subnetwork 4. So what is the pattern? When I consider the difference between the first IP and the last IP, that means last IP is 63, first is 0. If I get the difference, that is 63. I can observe the same here in the second subnetwork, 127 to 64. If I do the subtraction, this gives you 3, this gives you 6. That means the difference between the last and the first IP is 63 in all the subnetworks according to this configuration. Then what we have to do is we start the first subnetwork from 0 and add 63 into it. Then we got the last IP. This is the other way. We do the formal way to get it. We did that for the first two. Can't help, we have to do it. Then I'm giving you the way how to get the other two. Then observe the pattern. The difference is 63. First is starting from 0. Adding 63 will give you the last address of the first subnetwork. That's the same for the next one. When I go to the second subnetwork, that is starting from one after the last of the earlier final IP address 63. Adding 1 will be the starting of the next 64. Into 64, I may add 63, which becomes 127, 4, 3, 7, 6, 6, 12. I can do the same for the other subnetwork. If I go to subnetwork 3, 220.32.6, then what is the starting of this one? 1 after the last of the earlier. That means 127 is the last IP address, the previous one. This should be 128. Then how to get the last of the? Adding 63 into it. Then 8 plus 3 will be 1. Then 6 plus 2 and 1 will be 9. 191. We got it. 128 to 191. Fine. Then the other thing here is the next subnetwork. 220.32.6. 1 added to the last IP of the previous, 191. It becomes 192. How to get the last IP address of this one? Adding 63 into this. Then this becomes 5. This becomes 5. And this is. So we got it. So without wasting your time, you can find a pattern once you get IP addresses for the first two subnetworks. Luckily we had 4 subnetworks. If we had 8, then we can't do this the traditional method for all. Therefore, you better do the traditional method to find the first and the last IP for the first two and find a pattern. Use that pattern to the others. One more point. Now, once you consider all these 4 subnetworks, the subnet mask is not changing from subnetwork to the subnetwork. It's common. Based on the same subnet mask, we did the calculation. Therefore, subnet mask for all these subnetworks, all the 4 subnetworks is 255, 255, 255, 192. That's the one we have calculated in our first section, part 1. So then this is a common subnet mask and these are the IP address ranges for each and every subnet. Then regarding the question, they asked the network address as well. Network address is the first address of each subnetwork. Then for the first subnetwork, the network address is 220.32.6.0. Second subnetwork 220.32.6.64. Third subnetwork 220.32.6.128. Other one 220.32.6.192. So these are the network addresses for each subnetwork, and this is subnet mask for all the 4 subnetworks prepared earlier.